Hey there, kiddos. We are going to start solving systems of equations today. All we've done up to this point is just talk about how to set them up, what do they look like, what is the solution, what does it mean, but we haven't actually found a solution. So today we're going to start solving and getting solutions. And we're going to solve today using a method called substitution. It's one of three methods we're going to talk about. It's probably the most time-consuming method, so we do the hardest one first and then work our way to the easiest one so that it gets easier as we go. But before you do anything, bottom of your notes or on a separate sheet of paper, you need to pause the video real quick and you need to write down these 5 steps because I'm going to refer to them as we go through the video, and so you want to have them written down. It will help you as you are practicing this with me in class tomorrow. So let's start solving. I am going to go out of order on your notes. I'm going to do it on purpose because some of the equations are set up nicer than others. So we're going to go out of order. It's intentional. We're going to start with number 2. So you have 4x minus 3y equals 24, and then y equals 2x minus 10. And you saw that step number 1 said, if needed, get a variable by itself. Well, this is one of the times that it's not needed because a variable is already by itself. You should see that right here, this y is all alone because I have a statement that says y equals 2x plus 10. That tells me that I can take this 2x minus 10 and I can substitute it into y into the other equation. So that's the first thing I'm going to do. I'm going to take my first equation, 4x minus 3y, and in this case, y is going to be 2x minus 10 because it tells me in equation number 2 that's what y equals. And all of that is equal to 24. Now I have one equation with just one variable, and I can solve this and find out what x equals. So the very first thing we have to do is distribute to get rid of parentheses. So I'm going to bring down my 4x, and I'm going to distribute. This becomes negative 6x, and this becomes positive 30 because those two negatives make a plus. Now I'm going to combine my like terms. So I have 4x minus 6x, that's negative 2x plus 30 equals 24. And this is stuff you guys know how to do. We can solve a one-step equation with our eyes closed. So we're going to subtract 30 from both sides. So we get negative 2x equals negative 6, but it's 24 minus 30. And then when I divide both sides by negative 2, I get that x equals positive 3. So there is 1/2 of my answer. You are only halfway done with your problem at this point. This is what I meant by they are time consuming, because not only do I need to know what x equals, I also have to know what y equals because there's 2 variables in my problem. And if you remember, the solution to a system is where 2 lines intersect, and so it's a point on a graph. You need an x and a y value for that to happen. So I'm going to take this x equals 3 and plug it back into that y equals equation. So I have y equals 2 times 3 minus 10. I would just replace the x with the 3. So that becomes 6 minus 10, and 6 minus 10 is going to be negative 4. And step number 5 that you wrote down says to write your answer as an ordered pair because it is a point on the graph. So my ordered pair is 3 comma negative 4. And that's how we solve using substitution. Now if you look at question number 1, so we're going to back up. We're going to go over here to number 1. We're going to go back to step number 1 that says if needed, get a variable by itself. Well, if you look at the 2 equations in number 1, you have 2x minus y equals negative 4, and you have x minus y equals 8. You don't have any variables by themselves. You don't have anything that says x equals or y equals. So we've got to make that happen first. I'm going to do it in this bottom equation because both my x and y have a coefficient of 1. So just have a 1 in front of them. So I want to get this x by itself. To do that, I'm going to add y to both sides of my equation. So this becomes x equals 8 plus y. I now have an x equals statement. That tells me that I can substitute this 8 plus y in for x in the other equation. I'm going to change colors with my pen here so that it's a little bit easier to see what I'm doing. So stuff doesn't run into each other. So I have 2x, and in this case x happens to be 8 plus y minus y equals negative 4. So we're going to distribute again. So I have 16 plus 2y minus y equals negative 4. And we're going to combine like terms. So 2y minus y makes 1y. And when I subtract 16 from both sides, I get y equals negative 20. So that's my answer for y. But now I have to find x. So I'm going to substitute it back into this equation that I created when I added y to both sides. And I'm going to do x equals 8 plus negative 20. And 8 plus negative 20, or 8 minus 20, is the same thing, happens to be negative 12. And so my ordered pair for this problem is going to be negative 12, negative 20. So sometimes it's set up and you already have a y equals or x equals statement. You can go directly to substitution. Sometimes, though, it is not set up that way and you have to get either an x equals or y equals statement and then go to the substitution. So let's look at question number 4. Question number 4 is a little bit different because question number 4 says, if 3y equals 2x plus 7 and x equals 4 minus 3y, then x plus y equals whatever. We're trying to find what x plus y equals. Well, we can't do that until we know what x and y are, so we have to practice substitution. So step 1, if needed. Well, it's not needed here because this says x equals already. So I can substitute 4 minus 3y in for x. So I have 3y equals 2 times 4 minus 3y, because that's what x equals, plus 7. So we're going to distribute here. So 3y equals 8 minus 6y plus 7. Now I can combine like terms. In this case, they are numbers. So 8 plus 7 is going to be 15. So I have negative 6y plus 15. And I need all my y's together on the same side. So I'm going to add 6y to both sides so that it can cancel over here but end up over here. So I'm going to have 9y equals 15. And I got to get y by itself. So I'm going to divide by 9. And if you grab your calculator and do 15 divided by 9, if you do 15 divided by 9 on your calculator, you get one ugly repeating decimal. And you know by now that you cannot just write down a repeating decimal and be like, bam, I'm done. You better leave that a fraction. So we're going to simplify this fraction, 15 over 9. They'll both divide by 3, so this becomes 5 thirds. And that's what we're going to use and plug back in. I know that that is no fun. It is a fraction, but fractions are numbers too. So we're going to plug this in for y into our equation up here. So I'm going to substitute this y in now for my equation that I had up here that was x equals. So I have x equals 4 minus 3 times 5 thirds. So they weren't too horribly mean because they made this so it'll cancel. So I have 4 minus, now remember when I multiply 3 times 5 thirds, those 3's just cancel, leaving me with just the 5. And 4 minus 5 happens to be negative 1. And so my ordered pair solution is negative 1, 5 thirds. But that is not what they asked for in this problem. What they asked for in this problem was x plus y. Up here it's asked, that's what it's wanting. So I have to add them together. So I have to do negative 1 plus 5 thirds and come up with what that equals. And so I'm going to use my calculator. Negative 1 plus 5 thirds happens to be 2 thirds. If you don't want to use your calculator, then go ahead and common denominator it and do all that fun stuff, but your calculator will tell you it's 2 thirds. So that is the answer. And again, do not write it as a repeating decimal. So that is substitution. Sometimes you have to get a variable by itself, sometimes you don't. Let's look at one more problem. Look down at question number 8 on the back side of your notes. Question number 8 says, given the equations 2x minus 3y equals 0 and x plus 2y equals negative 7, what would you substitute for x in the equation 2x minus 3y equals 0? This statement right here, substitute for x, means they want you to have something that says x equals. So they want x to be the variable by itself. And they want you to substitute it into this equation, which means you have to take the other equation, and that's the one where you want to get the x by itself. So I want to get x by itself in this equation because I want to plug it into the other one. And the only way to do that is to subtract 2y on both sides. So I have x equals negative 7 minus 2y, and that's what x equals. And so to substitute in for x, I would do d, negative 7 minus 2y. So there you go with substitution. You'll practice this when you come in tomorrow, and I will see you then.